today we discuss GATE 2021 set 1 mechanical paper, and in this series we start the 1 mark question solving. The first question is the loading and unloading response of a metal is shown in figure. This is the figure, and the elastic and plastic strain corresponding to 200 megapascal stress respectively. Then this is the loading and unloading curve in stress strain diagram. The maximum stress is 200 megapascal, and this is the elastic curve, and this is the returning and strain. That means this is the elastic recovery, this is elastic strain, which is equal to 0.03 minus 0.01, which is equal to 0.02. This is elastic strain, and this is which not regain to its original position, just means origin 0. So this is the plastic strain. So plastic strain is 0.01 and elastic strain is 0.02. So the respectively is asking elastic first, then plastic next. So elastic is 0.02 and then plastic is 0.01. Answer will be option B, 0.02 and 0.01. Next question. In a machining operation, if a cutting tool traces the workpiece such that the directrix is perpendicular to the plane of generatrix. So this is the generatrix and this is directrix. So surface generated as. So this is generatrix and this is directrix. So directrix towards the x-axis. This is x-axis, and this is the rotation about x-axis. So the generatrix will produce a and cylinder. So option B is the correct answer. Next question. The correct sequence of machining operation to be performed to finish a large diameter through a hole. So we have to first perform drilling, which is small hole, then boring, which is relatively larger than the drilling, then reaming. Reaming is the surface finish of the boring. So first one is drilling, boring and reaming. Is the correct answer. Next, in modern CNC machine tool, the black glass has been eliminated by. So the black glass has been eliminated by preloaded ball screw. So is the correct answer. Next, consider the surface roughness profile as shown in the figure, which is the roughness height and this is the average length. So the center line average roughness array in micrometer of the measurement length is. So the average roughness RG we know summation of I is equal to 1 to N Y divided by number of times of. So it is equal to this is 1, this is 1, this is 1, this is 1. So total is 4 and number of cycle is 1, 2, 3, 4. 4 divided by 4, which is equal to 1. Option B is the correct answer. Next, in which of the following pair cycle both cycle have at least one isothermal process? So the Carnot cycle is, which is the TS diagram. This is isothermal heat addition and this isothermal heat rejection. So Carnot cycle also be one option. So option B is the only option where Carnot cycle is, and so option B will be correct answer. Let's see about Stirling cycle. Stirling cycle is just a type of Otto cycle. The one difference is these are the expansion and compression processor, PV is equal to constant, which is isothermal process. Temperature is constant, and the remaining process is heat addition is constant volume process, and heat rejection is constant volume process. And this is Stirling cycle, and the Otto cycle is this is constant volume process, this is constant volume process, and this expansion and compression are adiabatic. These are the adiabatic process, reversible adiabatic process. And this is PV axis. The main difference is this are the reversible adiabatic and this is the constant temperature process in case of Stirling cycle. So the question asked is at least one isothermal process. So these are the isothermal process in Carnot cycle, and the Stirling cycle has these are the isothermal process. So option B is the correct answer. Next question. Superheated steam at 1500 kilopascal has specific volume 2.75 meter cube per kilomole, and the compressibility factor Z is equal to 0.95. Then the temperature of the steam is around up to nearest integer in degree centigrade. So given data, pressure 1500 kilopascal and volume is 2.75 meter cube per kilomole, and compressibility factor is 0.95. So we know P is equal to nRT plus Z. P by N is equal to ZRT, where Z is compressible gas factor in case of real gas. So this PV star is equal to ZRT, and given pressure is 1500 and V dash is equal to 2.75 divided by N, the number of mole, is equal to 1, and Z is equal to 0.95, and R is equal to 8.314, which is ideal gas constant, and T is equal to temperature, where temperature we have to find from this equation is equal to 522.26 Kelvin, and we have to calculate in degree centigrade, minus 273.15, which is equal to 249. So option C is the correct answer. Next question. A hot steel spherical ball is suddenly dipped into low temperature oil bath. Which of the following dimension parameter required to determine instantaneous center temperature of the ball using Hazelitt chart? So Hazelitt chart required Biot number and Fourier number. Option A is the correct answer. Next, a infinitely long fin attached to isothermal hot surface transfer heat at the steady rate of a Q1 to the ambient air if the thermal conductivity of the film material is double. Thermal conductivity is 2 times of Q1 while keeping everything is constant, and the rate of steady state transfer from the fins become Q2. Q2 ratio of Q2 divided by Q1 we have to found. So we know Q is equal to root H P K area cross section into T naught minus T infinite. So all the parameters are constant and K is 2 times of K1. So Q directly proportional to root of K. So if K2 means the new thermal constant, thermal conductivity will be 2 times, then new heat transfer coefficient will be root 2 times. So the ratio of the Q2 divided by Q1 is equal to root 2. Option A is the correct answer. Next question. The relative humidity of ambient air at 300 Kelvin is 50% with partial pressure of water vapor equal to PV. The saturation pressure of water at 300 Kelvin is P saturation. The correct relation of air water mixture is. So we know relative humidity phi is equal to PV divided by PVS saturation pressure, partial pressure. So given phi is equal to 50%, that means 0.5, which is equal to PV divided by P saturation. So the PV is equal to 0.5 P saturation. So PV is equal to 0.5 P saturation. Option A is the correct answer. Next question. Consider a reciprocating engine with crank radius R and connecting rod of length L. The secondary on-balance force of case of equivalent to primary on-balance force due to vertical crank. So the on-balance secondary force we know F S2 is equal to MR omega square cos 2 theta by N, which is equal to M R by 4N into 2 omega square into cos 2 theta. So the comparing this R by 4N here the taken R is capital R, so no matter what R, so R by 4N, and N is the obligatory ratio which is equal to L by R, so R divided by 4 into L by R, which is equal to R square by 4L. So the radius is R square by 4L at the twice of engine speed, so engine speed is 2 omega, and this is the secondary force, this is the actually primary force. And comparing this, and we get so the answer will be radius R square by 4L rotating at twice engine speed. Next question, a cantilever being of length L and facial rigidity I subject to that an end moment M as shown in figure. The deflection of the beam at x is equal to L. Deflection at beam at x by x is equal to L by 2 is equal to ml square by 8EI, and C is the correct answer. Next question, prismatic bar of PQRST subject to axial load as shown in the figure, the segment having maximum and minimum axial stress. So this is the diagram where to draw ST section, which is 25 kilonewton, and this also be tension 25 kilonewton, and then this is the RS, which 20 kilonewton. We have to balance it. So extra will be 5 kilonewton, and this is also be 5 kilonewton, and this is QR, this is also 10 kilonewton. This tension must be 15, so this also compression and this is tension, and this whole section will be 15, so this will be 10 kilonewton, and this PQ, this is QR, this is RS, this is ST, and this junction is 10, and this is also 10, so there will be no stress. So maximum stress is ST section, and the minimum stress is RS, which is 5 kilonewton. So ST and RS is the correct answer. Next question. A shear stress distribution on the cross section of a coil where in a helical compression spring is shown in figure, the shear stress distribution is present, and this is the shear stress. This is which are the direct stress, and this is the also linear, so direct plus torsional. Answer will be combined direct and torsional shear stress. This form a linear stress, then direct stress, which is on symmetry. So the direct stress plus torsional shear stress in the coil or section. So option C is the correct answer. Next question. A pressure measurement device fitted on the surface of submarine located at depth h below the surface of an ocean. Read an absolute pressure of 4.2 megapascal. Density of seawater is 1050 kg per meter cube. The atmosphere pressure is 101 kilopascal. The acceleration due to gravity is 9.8, and the depth h is equal to. So this is the surface of atmosphere, 101 kilopascal pressure given, and the height h is equal to, we have to found in meter, and the absolute pressure is 4.2 megapascal. So pressure at A, this is A, is equal to 4.2 megapascal, and P atmosphere is given 101 kilopascal. Density given 1050 kg meter cube, and G is equal to 9.8. So we know the pressure PA is equal to rho G H plus P atmosphere. So PA given 4.2 megapascal, which is equal to 4.2 into 10 to the 6 Pascal, is equal to rho is 1050, which is density of seawater, and G given 9.8 is 9.8, and height we have to found, and plus P atmosphere given 101 into 10 to the power 3 Pascal. So after calculating we get height is equal to 397.9, which is equal to 398 meters. Answer will be option B. Next question. Consider a fully developed steady state incommensurate laminar flow of viscous fluid between two large parallel plate horizontal plate. The bottom plate is fixed and top plate with move with constant velocity u is equal to 4 meter per second. And the separation between plate is 5 mm and there is no pressure gradient in the direction of flow. And density of fluid is 800 kg per meter cube and kinematic viscosity 1.2 in 10 to the minus 4 square meter square per second. Press shear stress in the fluid is. So here the constant and the plate upper layer is moving with velocity given 4 meter per second, and this is the fluid having density 800 kg per meter cube and kinematic viscosity 1.25 into 10 minus 4, and the distance between horizontal and top plate is 5 mm is equal to h. So we know from Newton's law of viscosity tau is equal to mu dv by dh. So we have to find average shear stress, which is equal to tau is equal to given mu. So the kinematic viscosity dynamic viscosity and kinematic viscosity is equal to dynamic viscosity mu divided by rho. So the mu is equal to kinematic viscosity into rho. So rho times of kinematic viscosity. So rho given 800 into kinematic viscosity 1.25 into 10 to the power minus 4 into velocity change is 4 and distance is 5 mm in converted into meter 10 to the power minus 3. So calculating this we get 80 Newton per meter square, which is equal to 80 Pascal. So D is the correct answer. Next question. A rigid insulated tank is initially evacuated. It is connected through a valve supply line that carry air at constant pressure and temperature. These are 250 kilopascal and 400 Kelvin. Now the valve is open and air is circulated to flow into tank until pressure inside reaches 250 kilopascal. That means constant pressure at which point valve is closed. Assume that air behaves as a perfect gas and CP value given and final temperature of the air inside the. So CP is 1.005, which is perfect gas constant, and CP also 0.78. So gamma value is equal to 1.4 directly, and the final temperature. So this is constant pressure process. And temperature will changes, and this is the rigid tank with insulated tank. So the final temperature formula we know T2 is equal to gamma times of T1. So gamma is equal to 1.4 and temperature first initially is given 400. So this is also 560 Kelvin. Answer option D is the correct answer. Next, a figure shows, this is from the theory of machine gyroscope chapter. The figure shows the arrangement of heavy propeller shaft in a ship. The combined polar mass moment of inertia of the propeller and shaft is 100 kg per meter square. So given I value is 100 kg meter square and the propeller shaft rotate is omega is equal to 2n radian per second. The mass of acting on the ship while inducing rolling motion on the sun in the figure, and the angular velocity is, that means precision given 5 radian per second, and this is not precision, this is the angular rotation about z-axis. The rolling axis is equal to 5 radian per second, and the gyroscopic moment generated on the shaft due to moment is, we have to found the gyroscopic moment. The gyroscopic couple, I know I omega p, and given I is equal to 100 and omega is 12 omega p, as omega p as the axis of the rolling of ship and the axis of rotor are parallel. Axis of the rotor of ship and axis of the rotor are parallel, so there is no omega p, and that means no precision of axis, so omega p is equal to 0. So the gyroscopic couple will also 0. So answer option A is the correct answer. Next, this is also a sequencing problem. We have to arrangement the job process on the turning and grinding machine. So the new rule we have to apply. Then the minimum machining time will be for first one will taken at first side, and the minimum of the second one job will be taken on last side. So that's all. Please see this video and just watch what I say. So the minimum time is 1. So 1 is present in second machine, so we have to put in the last row. So total number of jobs are A B C D E F G 1 2 3 4 5 6 8. So divide the section in 8 box, 3 2 5 6 7 8 3 3 6 8. So first find the minimum time taken by the which job. So 1 is the minimum time and is present in second machine, that means grinding. This is first one and this is second one. So minimum time 1 is present in second one, so take it in last side, so B will be last. Then the next minimum is 2. 2 is present in first turning machine, so first taken in left side, which is A. Then next is 2, which is present in G, which is, and it is a machine time of grinding of second job, so taken in last side. Next to minimum 3, which is C, which is C, and it is a grinding operation, so it is second job, so put in the right side C. Next is 4, which is H, and it is in grinding second operation, taken in right side. Next 5, which is F, and grinding operation second side, so putting it right side. Next 7, which is the turning operation first side, so putting in left side. Next is only D, so the right sequence is AEDFHCGB, AEDFHCGB. So option A is the correct answer. Next question, activity A, B, C and D from the critical path for a project with PART network. The mean and variance of the activity duration of each activity are given. All the activity duration follow Gaussian or normal distribution and are independent to each other. So these are the mean and these are the variance given. So total mean will be 6 plus 11 plus 8 plus 15 is equal to 40, and we have to find the probability of project completed within 40. So expected time, that means the mean is equal to 40 and we have to found it TS expected. So the mean is the probability is TS minus TE divided by sigma, which is equal to which is Ts minus Te is equal is equal to 0. So in the thermal distribution curve, 0 represent 50% is equal to 0.5. The option B is the correct answer. Next question. Resistance spot welding of 1.55 mm thick metal sheet is performed using welding current of 10,000 ampere for a 0.25 second. The contact resistance at the interface of metal sheet is 0.0001 ohm. The volume of weld nugget formed after welding is 70 mm3. Consider the heat required to melt unit volume is 12 joule per millimeter cube. The thermal efficiency of welding process is. So we have to find the thermal efficiency of welding. So the melting efficiency, which is equal to the thermal efficiency, is equal to heat required to melt divided by heat supply. So heat required to melt is given. This is heat required to melt is 12 joule per millimeter cube, and millimeter cube is from a weld nugget of 70 mm3. So multiplied with 70 mm3, mm3 cancels, and heat supply, which is equal to I square RT, where I current, R resistance, and T is time. So put the value of I square. I is 10,000 square and R given 0.00001. The time is 0.25 second. This unit is joule, and joule cancel, so unit balance is maintained. So after calculating, we get 0.336, which is equal to 33.6%. And is the correct answer. Next question. Consider a single machine workstation to which job arrive according to Poisson distribution with mean arrival rate is 12 joule per hour. The process time of workstation is exponentially distributed with mean of 4 minutes. The expected number of job at the workstation at any given point of time. So the arrival rate given, is 12 joules per hour. Just a minute. So the arrival rate is given 12 joule per hour, which is lambda is equal to 12, and the service rate 1 by mu is equal to 4 minute is equal to mu is equal to 15. So the find expected job. So length of the system is equal to rho divided by 1 minus rho, and rho is equal to lambda by mu. which equal to 12 by 15. So rho, putting the value rho, 12 by 15 divided by 1 minus 12 by 15. 12 by 15 is equal to 4 by 5 divided by 1 minus 4 by 5, which equal to 4 by 5 divided by 1 by 5, is equal to 4 by 5 into 5 by 1 is equal to 4. So the expected number of partition, that means length of system, is equal to option B, 4. Next, a solid sphere of radius 10 mm is placed at a center of hollow cubical enclosure of side length 30 mm. The outer surface of sphere is denoted by 1 and inner surface of the cube is denoted by 2. And the view factor 2 have to calculate it. And this is the solid sphere placed at the center of the hollow cube inside the outer surface of sphere is denoted by 1. The inner surface of the cube is denoted by 2. So given R1 is 10 mm and area is equal to 4 pi R1 square is equal to, later calculated, and A2 is cube area is equal to 6a square, and area जो side length is 30 mm, so 6 into 30 square, and f1 to 2 is equal to p factor 1 to 2 is equal to 100%. So by reciprocating rule, a1 f1 is equal to f2 f21. So we have to found f1 is equal to a1 by a2 into f. So a1 given 6 into 30 square divided by 4 pi into r1 is 10 square into f1 2 is equal to 1. F1 is calculated from this, we get 0.2327. So we know f22 plus f21 is equal to 1. So f22 is equal to 1 minus f21 is by summation rule. So 1 minus 0.2327 is equal to 0.76 equal to 0.77. Option D is the correct answer. So the next question, let's sort so drum the radius given 260 mm and brake is shown in favor. A force of 1 kilonewton is applied to the lever and the coefficient of friction is 0.4. We have to find the magnitude of torque applied by the brake. This is actually 2-mark question and we have to solve. So taking the moment about O, this is point O, So, and the reaction is experienced by Rn, and this is the frictional resistance offered by the drum on the rubber brake is Fr. And taking the moment balance, so Rn into 500 the distance plus Fr into, which is 310, and the radius is 260, so 310 minus 260, which is equal to, this is 1 kilonewton, this is 1000 newton into 500, this is also 1000. So this Fr is equal to mu times of Rn, and mu given 0.4 into Rn. So by solving this, we get Rn is equal to 1923.07 Newton. So frictional resistance is equal to mu times of Rn, and mu is given 0.4 into 1923.07, which is equal to 769.23 Newton. And the frictional torque is Fr into radius of the drum, and Fr given 769.23, and the radius of drum is 260 mm, which is equal to, or 260 you can write 0.26, so by hand calculated is 200 Newton meter. Option C is the correct answer. That's all the solved. 2021 that day, 1 mark question. The next class we solve 2021 set 2 paper 1 mark.